Welcome to our channel. So in today's lecture, we're going to talk about how to find an outlier in the statics data. And this question is taken from the exam paper of Kingston University. In this question, I will just highlight the main thing in the question. So basically, two laboratories are doing some observations measuring the amount of pentachlorophenol in drinking water, and they got these values using solid phase micro extraction and GCMS. The other laboratory is using solid phase extraction with LCMS. So the main thing is that is there any outlier in repeatability data? Is there any outlier in this and in this data? So we're gonna find out quickly how to find the outlier in this data. So in the first case, for laboratory A, our data is this one. There are 6 data sets. So I have mentioned the same that are mentioned in the question. Then in the first case, to find out the outlier, you need to arrange your data in ascending order. Like the smallest value in this one is 0.01. I mentioned over here, then 0.08, then 0.09, 0.09, 0.10. You can write it as 0.10 and 0.10. So first thing you need to do is arrange data in ascending order. Then you need to find out the gap and range. Range means the lowest and the highest value, and gap for that you have to have two values. One is the gap between first two values, and one is the gap between last two values. I haven't taken the last these two. If these two values are same, then we have to skip this value and take the other one that is different. So there are two gap and one range. So we need to find out two values for the outlier. The outlier formula is gap over range. I will find out these two values. No, for the first data set, this one we call it as QS, or we can also call it the outlier, smaller outlier. So for this, the gap is this one 0.08 minus 0.01, and the range is 0.10 minus 0.01. So I have mentioned the values. The answer is 0.78. You have to remember this value, and we have to use the same method to find out the other outlier. So for the large set, this gap over range, same values. In this way, the gap is 0.10 minus 0.09 divided by range is same 0.10 minus 0.01, and that becomes 0.11. So we have to find out, we have to discard either the highest value or the lowest value using that outlier method. So we have 0.78 and 0.11. So if this is the outside of our critical value, then we have to discard this value. And if this is outside our critical value, this one, if 0.78 is outside our critical value, we have to discard the first one. So we will check using the Dixon table. I will show you in a while. So you will see that the critical information is like number of observations 1, 2, 3, 4, 5, 6. So number of observation is 6. Confidence interval that we take is 95%. So number of observation, we have to check the values from Dixon table, and it shows the number of observations, and we have to check in the sixth column, and with 95% confidence interval you will get the critical values at 0.625. This is the critical value. Now we have to compare this value with our two outlier values 1 and 2. So when you see that 0.625, this value is within the critical range, so there is no outlier on the right hand side or QL. On the other side, our QS, our left hand side, our values is 0.78. So this value is greater than the critical value. If any of these values, first you have to calculate, if any of the value is greater than the critical value, then that one is outlier. So clearly, so this is not an outlier. We have to check across which value. So this is for the smaller left hand side. So we can say that this one, this is an outlier. So that can be discarded, and these are the actual set of values. So 0.78 greater than critical values, that is 0.625. So 0.01 is an outlier in the data set and can be discarded. In the similar manner, for the laboratory B, you can arrange the values in the ascending order, find the two values, and check in the Dixon table and find out if there is an outlier in that value or not. If you have any question, you can ask in the comment section. Thank you so much for watching.